Hey everybody, it's Mrs. Bakaki again. We're going to continue with section 5.1. 5.1 continued. And the topic of this short video are maximum and minimum values of a parabola. So I sketched two random graphs, and I want to know what the max or min values are. And how do I know if I have a maximum or a minimum? Okay, so I can tell you by looking at this graph, I have a maximum value. Max value. Okay, and in order to find our maximum value, all we need to know is our vertex. What is my vertex? Okay, essentially our vertex, which is right here, is the highest part of this graph, the maximum value of this graph. Okay, so what is our vertex? Just by looking at the graph, it looks like we go over 1, 2 units and go 1, 2, 3, up 4. That is my max value. Okay, let's go over to this graph. I'm sure you can guess we have a minimum here, and all we need to do is find what our vertex is. That'll give us our minimum value. We go over 1, 2, 3, 4. I'll put min value. And we go over 4, to the negative 4 and up 1. That is my min value. So something you can kind of remember, and maybe it'll stick in your head. When I want to differentiate between max and min, I need to look for something that looks like a hill for a maximum value, and something that looks like a valley. Those didn't quite go where I wanted to. Something that looks like a valley for a minimum value. Okay, why is that? Well, basically, this is the maximum point at which our graph exists. Nothing else goes on up here. Okay? It's not defined. But it goes on forever and ever. That's what these arrows essentially mean. It goes on forever, making there be no minimum value at all. Only the maximum exists. Same goes for this graph. This goes on forever and ever in the positive direction. But this is the lowest point, or the minimum point of the graph. Nothing else exists beyond that. So that's why we call it the minimum. Okay, so we're looking at max and minimum values based on a graph. What if I'm just given an equation, and you can see this as y or f of x? Remember, they mean the same thing. What if I'm given this equation of this quadratic? First of all, am I going to have a max or a min? How do I know just by looking at it? Well, I know this quadratic is positive, okay? There's nothing out in front. If it's positive, it's going to open upwards, right? And this will give us, my dogs are playing around, I'm sorry, so you might hear them barking at each other. So this will give us a minimum value. Here we have our hill shape, and that'll give us our minimum value. So we're looking for a min. And how do we know if we don't see the graph of the function? Well, we can use what we learned when we talked about axis of symmetry, that formula, negative b over 2a, that'll give us our x value. Okay, well that's great. I need a coordinate. I need an x and a y value. So what can I do after I find that x value? Well, I can plug it back into my equation and solve for y. So let's do that. First of all, what are my a and b terms? A is 3, b is 12, and c is 8. We don't need c at this point in time, but it's good to know. So negative b, or negative 12, all over 2a, 2 times 3, which is 6. That gives us negative 2, which is our x value, which is also our axis of symmetry. Okay, So we found that. Now I want to take that negative 2 and plug it back into our original equation. So I have 3 times negative 2 squared plus 12 times negative 2 plus 8. Okay, so order of operations tells us to look at exponents first. I have one here. Negative 2 squared is 4. 3 times 4 plus 12 times negative 2 is negative 24 plus 8. 12 minus 24 plus 8 is, let's see, negative 12 plus 8, or negative 4. So that gives us our minimum of negative 2, negative 4. We'll do more practice with this in class. Enjoy this cold, snowy day.